Hello and welcome to the Unit 5 review video. This video will go over the study guide that was handed out last week. Number 1, what are the 4 indicators of chemical change? Smell change, color change, temperature change, and formation of gas or a precipitate. So let's write those down here. Temperature change, remember this triangle is delta, which means change. Color change, smell change, and formation of gas or a precipitate. Precipitate, PPT, is just the abbreviation for precipitate, and that's just meaning a solid is formed. Now think back to the reaction we did in class where we had the flask with water and universal indicator in it, then the Alka-Seltzer was dropped in. The color change from blue to green to yellow. The temperature also changed, and we saw formation of gas. So that was a good reaction because it showed multiple signs of a chemical change. It says to give an example of each. Temperature change, that's easy. If something's getting colder or warmer, that would be an example of a temperature change. Color change, also easy. If you see something go from one color to another, that would be a color change. Smell change, if you smell something strong that was not there previously, that would be a good example of a smell change, which suggests a chemical change has occurred. And then finally, formation of gas. Phrases for this include bubbling or foaming. If you see that within a description, it's most likely a chemical reaction. Or for precipitate, if it says a solid was formed, that would be a precipitate. And so those would be examples of that. Is the action of a tomato rotting a chemical change? Yes, it is, because if you have a tomato rotting, the smell is going to change and the color will change. It will go from red to brown. And so those two items suggest that it is a chemical change. 3, you turn on a lawnmower. Is this a chemical change? Now, this is referring to a gas lawnmower. So, you know, the kind you pull to start. When you start that lawnmower, the color of the gasoline changes because there are many explosions going off in the engine that cause it to operate. So color change, definitely a smell change as that gasoline explodes in a controlled manner. So you've got color change, smell change, definitely a temperature change as if you were to touch the lawnmower, it would get hot. And also formation of gas, because that gasoline, as it explodes, it's going to put out exhaust, which will be in the form of gas. Now, same exact thing happens when you start your car. You've got color change, temperature change, smell change, and formation of gas, which suggests it is a chemical change. So what I hope you've learned from this is that if you're wondering if something is a chemical change, think back to those 4 items and it will help you realize if it is or not. Number 4, what is the law of conservation of mass? Remember, law of conservation of mass says that if nothing is added or removed, sorry for the sloppiness there, from a system, the mass stays the same. Okay, you can think back to the examples we did at the beginning of the year, such as spreading the steel wool. Remember, everyone thought that it would cause the mass to stay the same, but little particles of steel wool were falling off from it, which then caused the mass to decrease because particles were leaving. Or the reaction where you have 2 test tubes and you combine them and a solid form. Many of you thought that the mass would increase when in fact it stayed the same because no particles entered or left. Number 5, one liquid has a mass of 5 grams and another has 2 grams. When combined in a beaker, they form a heavy solid with no liquid left. What is the mass of this new solid? Well, because of the law of conservation of mass, even though it is a heavy solid, the mass of that solid can only come from these chemicals. And so the mass has to be 7 grams. 5 plus 2 is 7. Nothing has entered or left, so the mass stays the same. So it's 5 plus 2. Mass cannot come from without particles being added or taken away. Number 6, a student burned magnesium with a Bunsen burner. Complete her table and explain whether her results agree or defy the law of conservation of mass. Okay, well, the original strip here, the name of it was magnesium, which we'll just put as Mg. And now it's burned and it has a mass of 3.3 grams. We saw this same thing with the steel wool. When you put steel wool into a Bunsen burner or into a flame, the mass increases. Now, a lot of students will say that this violates the law of conservation of mass, because how can the mass increase if no particles were added or taken away? Well, particles were added. There's oxygen particles in the air which will bond with the, in this case, magnesium particles and cause the mass to increase. That means the name of this substance is going to be magnesium oxide, and this oxygen came from the air surrounding the magnesium. So, do her results agree with the law of conservation of mass? Yes, the mass increased because particles from the air were added. That's why. Number 7, what are products? What are reactants? So let's say I have this reaction here. We'll call these A and this B. The products are what are produced, the ending stuff. The reactants are the starting ingredients, like milk, eggs, chocolate chips, flour, to make cookies as our products. 2 ways to remember this. If you can remember RIP, reactants come first, products come second. Or you can remember the arrow points to the products. Points to the products. Products always come last.